Okay, class. So this is the second part of the presentation for constant temperature process. Okay, so this presentation class gives you an example of what was derived in the first part of the presentation. Okay, so by this time we are going to take an example to apply the formulas derived and to familiarize problems for constant temperature. Okay, so let us consider this example. If 10 kilogram per minute of air are compressed isothermally from P sub 1 equal to 96 kilopascal and B sub 1 equals to 7.65 cubic meter per minute, to P sub 2 equals to 620 kilopascal. Okay, find the work, the change in entropy, and the heat for A, non-flow process, and B, for steady flow process with velocity at 1 equals to 15 meter per second and the velocity at 2 of 60 meter per seconds. Okay? So let us now take the solution for this. So for non-flow process, so previously derived for the work non-flow. So work non-flow is equals to P sub 1, B sub 1, ln of B sub 2 over B sub 1. And from the equation for PBT relation, P1, B1 is equals to P sub 2, B sub 2. Okay? So determining B sub 2 now, since P sub 1, B sub 1, and P sub 2 are all given. So the final volume now is equals to 1.1845 cubic meter per minute. Okay? So for the work non-flow now, so substituting values, that is 96. So the value of the pressure multiplied by the volume, 7.65, and the natural logarithm of 1.1845 and 7.65. Okay? So the work non-flow now is negative 1370 kilojoules per minute. Okay? So for the heat now, heat transferred, Q is equals to delta U plus work non-flow, but delta U is equals to 0 class. Okay? So that is for T is equals to 0, delta U is equal to 0. Okay? So, therefore, delta U is equals to 0. So, Q now is equals to the negative work non-flow. Therefore, Q now is equals to negative 1,370 kilojoules per minute. Okay? So, for the change in entropy class, okay? Change in entropy equals to MR ln of B sub 2 over B sub 1 is also equals to MR ln of P sub 1 over P sub 2. But also, we can also solve delta S equals to dQ over T ln of, or limit from 1 to 2. Okay? So PB is equals to MRT. Determining T now, that is equals to 256 Kelvin. Okay? So substituting values now for Q and T. Okay? So change in Q equals to negative 1370, and then T over 256. Delta is now equals to dQ over T is equals to negative 5.354 kilojoules per minute. Okay? So that is for non-flow process. Okay? So take note that steady flow is also required. Okay? So for Q, so getting now the equation for steady flow energy. Okay? Or SFEE, steady flow energy equation. Where Q now is equals to delta U plus W plus delta P plus delta K plus delta H. But delta U is equals to 0. Delta P is equals to 0 also, and delta H is equals to 0. Therefore, Q is equals to W plus delta K. Since velocity are already given, so we can compute the change in kinetic energy. Okay? So, getting now the change in kinetic energy, that is 1 over 2 multiplied by 1,000 multiplied by 10 multiplied by the change in velocity of 60 meter per second square minus 15 square. Okay? So, the change now in kinetic energy is equals to 16.875 kilojoules per minute. Okay? So, getting now the work steady flow. Work steady flow is equals to the work non-flow minus the change in kinetic energy. Therefore, the value now for the work steady flow is equals to negative 1387 kilojoules per minute. Okay? Thank you very much, class. That ends my presentation.